What's up? It's Richeski here, coming at you live from fifth period. What's up, everyone? Oh, God. All right, so if I plug in -1, as I was saying, this would be like undefined, or if you want to write NA for not applicable, because we're not going to look at these functions if the output is an imaginary or complex number. So we're just going to only look at real number outputs. So let's look at 0 now. When I plug in 0, Sarah, what is the square root of 0? 0, that is correct. What's 0 plus 2? 2. Awesome. Let's plug in 1. What's the square root of 1? That's the square root of -1. But again, we're gonna pretend like imaginary numbers don't exist, which they kinda, I don't know. They do exist, but they're made up. So what's the square root of 1? 1. What's 1 plus 2? 3. What's the square root of 4? What's 2 plus 2? What's the square root of 9? What's 3 plus 2? So, when the table is done for you, oftentimes the radicand, which again, the radicand is just a fancy word for the expression or number inside a radical, a lot of times that's going to be a perfect square. If you're making up the numbers on your own, which you will do eventually, sometimes it's better to purposely pick numbers so that the inside is a perfect square, like 1, 4, 9, 16, and so on. So anyways, let's go ahead and graph this. So 0, 2 would be right here. 1, 3, 4 would be about there, and then 9, 5 would be roughly right there. And this is going to be the general shape, if I could draw it a little better, of my graph. All right, I'm going to pause our video, and the class is going to work on B. If you're watching this video at home, I encourage you to pause the video and try it on your own. Recording again. All right, welcome back. Hopefully you had a chance to try this problem on your own. If you plug in -3, the radicand will become -1, so that is not applicable. If you plug in -2, radical is 0, or radicand is 0, square root of 0 is 0, square root of 1 is 1, square root of 2 is 4, square root of, that didn't make sense. Square root of 4 is 2, square root of 9 is 3. -2, 0. -1, 1, 2, 2, 7, 3. All right, so that's our warm-up. Below, did I mute myself? No, there we go. Below is the parent square root function. Why do you think the function starts at 0, 0? This is the equation, y equals the square root of x. Why would this function have a starting point at 0, 0? Anyone? So one way you could think about that is that anything lower than 0 is not going to be able to be plugged in because we'll get imaginary numbers. So the smallest thing you can plug in is 0, and the square root of 0 is 0. So that's why it starts at 0, 0. Since the function starts at 0, 0, the domain is 0 to infinity. The range is also 0 to infinity. Okay. number one. This is very similar to the do now. Number one says identify the domain and range of each square root function. So, what would be my domain here if that is my starting point, 1, 2, 1, 2? What would my domain be? Gabby. What's the lowest x value I have here? One. I'm going to put that 1 in a bracket, or, well, I'm going to start with a bracket. How far to the right does it go now? Sarah? Infinity. Whenever you're using either infinity or negative infinity with interval notation, you put a parenthesis around it. Always a parenthesis with infinity or negative infinity. The reason is because it's like infinity is more of a concept than a number, right? I don't know. That's how I remember it. Range. How low does this graph go? 2. Again, I'm going to put that in a bracket. How high does it go? Infinity. Good. Next one. Did Monet ever come to class? No. Sad. Domain. What is the domain? That's going to be in the video, by the way. -3 to what? Infinity. Good. And how about the range? 2. Good. Questions on that? Easy, right? So simple. Okay, let's scroll down or flip over to page 2. Page 2. All right. So it says below is the parent cube root function. This parent function has, now we call it a center point instead of a starting point. So it has a center point at 0, 0. The domain and range for all cube root functions is -infinity to infinity. And I will add something to this. This is not only true for cube root functions, but it is also true for any odd root. So what's another odd number? Okay, but that's 3. That's cube. Another one. 7. The 7th root would also look pretty much like this. It would be more like that though. But yes. Okay, so let's take a minute to practice graphing some of these parent functions with our calculators. So if you could, if you do not already have a calculator, let's take one out. I'm going to pause the video here and I'm going to do this just with the class. So we will see you in a minute.